This winder operation safety training consists of the following major sections: the general winder safety expectations, hazards by area of operations, and common safe practices. The general winder safety expectations portion explains some of the general dangers of operating the equipment and your responsibility as a team member or employee. The hazard by areas of operation portion of this CBT goes into greater details of hazards associated with the specific areas of the winder. These areas are broke down into the following 3 areas: the parent reel through the unwind portion of the winder. This would include, but is not limited to, the broke holes, reel rails, and spools, as well as the process of chucking up the parent reel. The lead-in rolls to drums area of the winder, which would include, but not limited to, nips and pinch points, slitters, core chucks, cut-off knife, roll ejectors, and other components in the area. This also addresses sheet brake cleanup, under-winder access, and accessing drums. The roll discharge and cradle areas of operations addresses known hazards around, but not limited to, the roll stops, rolling over roll stops, cradle operations, and cradle pinch points. Safe practices portion of this CBT looks at the automatic operations of the winders, the threading process, performing front drum splices, and emergency extraction processes. Start, stop. The paper machine winder is one of the most dangerous pieces of machinery in the paper mill. It is a start and stop operation which consists of many dangerous and hazardous areas, with equipment that may move automatically, pinch points that can injure you without warning, and sharp parts that can cut you severely. You must always be aware of what is happening at the winder when you are near or in the area. Hundreds of careless injuries and near misses in our paper mills occur at the winder every year, and several people have been killed in recent history. Every winder is unique, with different arrangements. They come from different manufacturers, they run different paper grades and weights, and each may have slightly different hazards and dangers. All winders are different, but use the same basic principles of operation that provide excellent products for our customers. If you are familiar with one winder and are now in the area of another winder, be aware that different hazards may exist. Standard operating procedures for each winder are also unique and must be followed at all times. Care enough to intervene. Caring enough to intervene on the behalf of others to keep them from getting hurt. It is your duty to intervene when you see unsafe acts, unsafe processes, and unsafe conditions. After many years of winder operations, we may have formed habits that are not the safest way to complete a task. These habits lead to injuries over time and can be avoided by keeping focused on hazard awareness and being willing to change to safer practices. Before starting the winder or any operator control function, the winder operator should assure he has line of sight. Line of sight operations is defined as the winder operator having a direct line of sight to the component of the winder he or she is operating. Due to the size of the winder and the inability at times to have a full view of every inch of the winder, it is expected that the operator pushing any control button will know the location of all winder crew members and others in the area prior to starting any winder movements. Ensuring we are using line-of-sight operations can have a positive impact on safety at the winder. Most serious injuries could have been prevented by knowing the positions of people and how the winder operates. Examples of where line of sight is required are rider roll movements, moving the cradle, nip barriers, core chucks, jogging the drums, and other pieces of equipment. Winder operator responsibility. Winder operators are responsible for the safety of themselves and the safety of others who are working or assisting in the winder area. Be aware of anyone who might have entered the winder area. This could include maintenance workers, sales staff, and onlookers. When other employees flow into the winder area, they should check in with the winder operator to make them aware of their intentions. Operators can then inform them of any hazards that may be present in their area of operation. The winder operators are ultimately responsible for the safe operations of the winder. Lock out the winder. If you need to place your body or body parts into the winder other than your normal safe practices, you must lock out the winder. Lockout, tagout does not only mean the winder drives on the winder. There are many other areas of the winder that need a form of lockout during operation. Pneumatic pressures, hydraulic forces, and gravity need to be considered when making an area safe to perform work. Potentially dangerous areas are nip points at a knife, sheet clamp, roll ejector, cradle, rider roll chucks, threading nips and pans, to mention a few. There must be a documented lockout-tagout process for all components of the winder. This process would direct employees on how to safely lock out the equipment, whether it's hydraulic valves, pumps, air valves, and electrical components, or any combination of these. Checking the operations of the winder safety devices on the winder will be documented. Basic safety equipment should be tested on a daily basis. Examples of basic safety equipment: bump switches, safety mats, photo eyes, proximity switches on safety gates, and e-stops. No safety device will be bypassed unless there is a written safety procedure in place to follow while the device is being passed. This temporary procedure should be clearly understood by each winder crew member and know how this will affect how they perform their normal job. Threading. Each mill should establish a minimum number of people that are required to thread each winder. Each winder crew should be aware of this minimum number and what their role is in threading the winder. This number will vary because different winders have different levels of automation. The number of people needed to thread the winder during the splice process may be different than the minimum number to thread the winder. Each mill should establish a minimum number of people that are required to splice each winder. Once again, this will vary due to the different sizes of winders we have and their varying levels of automation. Safety signs for all primary hazards must be in place, legible, and understood by anyone in the area. This includes visitors. All winder operators and crew must understand all of the safety devices on the winder, such as lights, buzzers, interlocks, etc. All winder operators and crew must know the locations of all e-stops. All winder operators must understand the automation sequencing in both semi-automatic and automatic modes. A clear understanding of how to manually perform set changes when automatic sequencing fails or stops for some reason is critical to understanding the automatic sequencing. SOPs. There shall be winder standard operating procedures and safe practices. Each mill shall have documented specific SOPs that ensure safe practices. All winder crew members shall be trained in and must follow the SOPs. All winder personnel must be able to access SOPs at any time. It is vital that all winder crew members understand the automation sequencing in both semi-automatic and automatic modes that may be used on a particular winder. They must know what moves, when and where, while the sequence is in auto and semi-automatic modes. A clear understanding of how to manually operate and perform set changes is critical to understanding the automatic sequencing. There will be times that manual operations are necessary when automatic sequencing fails or stops for some reason. Line of sight operations is a critical key to safety here as well. Maximum run speeds. The winder run mode should be limited to a not to exceed maximum safe speed while people are working in and around the slitter section and or the unwind area. Each mill will define their own safe speeds and distances based on the products they are producing. Safe speeds typically would be 1,500 feet per minute on winders running on containerboard types, grades of paper. There may be slightly higher safe speeds for winders running lighter grades, such as newsprint and fine papers. Some mills may even fully restrict access to these areas during winder operations. The more restrictive procedure is the safest and should therefore be followed. Never walk under suspended loads, no matter how secure they may look. Suspended loads do include an empty spool in a strongback or the crane. The strongback itself is considered to be a load as well, and a full reel in the strongback is most definitely a load to stay clear of. Hazards by area of operation. There are many basic elements of a safe winder operation that must be followed. Within these elements, you will find numerous hazards. These hazards identified in this CBT have been sorted by areas of operation. Sorting by areas will allow us to get into greater details and further our understanding of the hazards associated with each specific area of the winder. These areas are the parent reel through the unwind portion of the winder. This would include, but is not limited to, the broke holes, reel rails and spools, as well as the process of chucking up the parent reel. The lead-in rolls to drums area of a winder, which would include, but is not limited to, nips and pinch points, slitters, core chucks, cut-off knife, roll ejectors, and other components in the area. This also addresses sheet brake cleanup, underwinder access, and accessing drums. The roll discharge and cradle areas of operations addresses known hazards around, but not limited to, the roll stops, rolling over roll stops, cradle operations, cradle pinch points. Safety guards, signs, and pinch points. Here in the parent reel through the unwind portion, we start with guarding of hazards. All guards and spline covers or reel spool shrouds must be in place and in good working order according to all manufacturers' recommendations and OSHA regulations. All of the manufacturer's original signs must be in place. You must always be aware of pinch points. Some pinch points can occur during the chucking up of a parent reel. They are located at the empty spool to parent reel to floor, parent reel to parent reel. More pinch points. Some more pinch points can occur during the chucking up of a parent reel. Some known pinch points are between the reel rails and the spool, where the spool comes in contact with the unwind saddles or cushioned reel stops, where the chuck meets the spool, and along the movable sections of the reel rail. Suspended loads. Be aware of suspended loads and never be under them. Examples of suspended loads are empty spools, spools with paper on them, strongbacks with nothing on them, and even items being carried with the crane for maintenance. Be extremely aware of swinging crane hooks, kickbacks, and failure of cables during the process of putting a parent reel into the unwind stand. Some mills have cameras so the crane and winder operator can clearly see the backside of the reel spool. No one should be in the slitter area when loading a paper reel into the unwind or when removing an empty reel spool from the unwind. In the unlikely event that a reel spool journal or crane would fail, this could be a major pinch point. OSHA standards for broke holes. OSHA standards for broke holes shall be followed. OSHA requires that a guardrail shall be provided at broke holes in accordance with American National Standard A12.1-1967. Where pulpers are located directly below the broke hole on a paper machine, and where the broke hole opening is large enough to permit a worker to fall through, any employee pushing broke down the hole shall wear a safety belt attached to a safety belt line. The safety belt line should be fastened in such a manner that it is impossible for the person to fall into the pulper. Each mill should determine the process for safely guarding the hole and the distance at which point a person would be required to wear a safety harness. Be aware that you can fall, slip, or trip when working around broke. The floor can become an uneven working surface as broke accumulates on the floor. It is important to use fall protection where you have the potential to fall into broke and be pulled into the pulpers. Never stand on paper when it is moving towards the pulper. It can take you right into the pulpers. Reel spools. Always maintain a safe distance from the reel and spools to avoid being caught by the paper during a sheet break or hay out at the winder. The safe distance must be established and communicated at each mill. Paper grades, types, winder speed, number of sets on the reel, etc. may cause this to vary. A suggested reasonably safe distances would be never less than 4 feet and generally not greater than 12 feet. There should be annual reel spool inspections. Reel spools have the potential to crack over time. These detectable and preventable failures are usually pretty catastrophic in nature. Each mill should have a detailed and documented regular scheduled, possibly annual, inspection process for each spool that includes the spool journals. Nip and pinch points. The winder is full of many nips and pinch points. Some of these are the threader pans, threader rolls, slitter rolls, and lead-in rolls. Body parts can be pinched and pulled into the machine at most of these points. The nip of the slitter blades and bands are not only pinch points, they are very sharp and can severely cut you. The winder drums create a nip point with a roll of paper on them. Serious injuries and deaths have occurred at this ingoing nip. Line of sight operation when jogging the drums is a must. Even at slow thread and jog speeds, the winder can pull you in before coming to a complete stop. The gap between the front and the back drum can be narrow, and you can get caught between them. If you are beneath the winder and your hand gets caught, serious injury can occur before the drums are stopped. Details of front drum splicing will be provided in the Safety Practices section of this CBT. Some additional potential pinch points in this area of the winder, which you must be aware of, are at a cutoff knife, sheet holder, sheet clamp, the roll ejector, a core injector. Once again, make sure that all of the manufacturer's signage is in place. Pinch points in this area don't only occur as the paper is being threaded or wound. They can occur when unloading and disengaging equipment also. Be aware of slitters. Hand injuries are the #1 type of injury within Weyerhaeuser. It is a leading type of injury at the winder while working on slitters. There are almost as many injuries working around slitters as there are when changing slitter blades. Serious cuts have been caused by not knowing exactly where the slitters were when threading the winder, when dropping a tape measure, when setting them, and accidentally bumping a slitter when picking it up. When picking up a dropped roll of tape that fell into the trim chute, or even when pushing or relocating slitters to a new position for an order change. These are all preventable accidents that have occurred. Always be aware of where you are and your surroundings while in the slitter area. Slitter area threading caution. There may be orders that require that a slitter be positioned close to a thread or pan. This can be very dangerous. When the tail is threaded through the slitter section, you must be very careful where to direct the tail and that there may be a slitter nearby. When you release the tail and pull your hands back, you can bump a slitter. If the tail is not feeding properly, too much slack, or piling up, or feeding on the wrong side, you may hurry too quickly so that you can react to the threading and accidentally bump a slitter. You must be extremely careful when threading, and if something goes wrong, stop the threading immediately. There may be air assist or threading pans that can be added or modified to a threading system to make it safer to thread. Slitters. Always allow the slitters to come to a complete stop on their own before getting near the slitters. Do not work on any slitters unless they are properly isolated and are at zero energy state where they cannot be started. Lockout procedures are different for each winder. Some operations require lockout of the slitter motors when positioning the slitters manually. Other operations require lockout only when changing the slitter bands and not when changing the slitter blades. Always follow the lockout procedures for each particular winder. Use caution around the slitters. They have been known to disintegrate while running at speed, and especially at high speeds. Slitters have also been known to come off while operating. Always be aware of these facts and be careful around slitters. Safe practice for changing slitter blades and bands. These are the components of safe practices that should be followed for changing the slitter blades and or bands. You must wear cut-resistant gloves when handling the slitter blades or bands. When loosening or tightening the slitter blades, be very careful when holding back the slitter blade while using a wrench. Many Weyerhaeuser injuries have occurred while holding the blade with fingers in one hand and working with an Allen wrench in the other hand. To avoid this type of injury, a slitter blade changing tool can be used. Mills should look into purchasing a slitter blade changing tool or building one to use. The slitter's power should be locked out and tested to ensure zero energy state so that they are not started by mistake. Key switches are common disconnects for this type of routine tasks. Be aware of possible pinch points when disengaging and moving the slitters. The slitter assemblies can hit each other on some models. Be sure that any guards are in place and that the pinch point is labeled. When replacing slitter blades or bands, leave the plastic coating on the blades and bands until they are fully installed. Some mills grind their own slitter blades and there is no plastic coating. Be very careful near the slitter blade cutting edge. Core chucks. Be aware of the core chuck slides and that they can move automatically. They should have proper guarding to protect the winder crew members when they move up and down. Once again, all original manufacturer's safety signs must be in place to identify potential hazards in this area. There is a possible pinch point on the interior portion of the winder at the winder drum area when the core chucks are moved to the lowered position. The operator should only engage the core chucks into the cores when he has a direct line of sight and can see that there is no one or an obstruction in the way. Mills should consider interlocking a safety mat or laser light in front of the drums before allowing the core chucks to chuck up. Never reach into the drum pocket or core chucking area if there is an automatic or semi-automatic chucking sequence in progress. The area should be properly guarded. Cut-off knife, SOP. Your mill must have an SOP in place for safely working on or around the cut-off knife. This should include proper lockout and testing for zero energy state, clear communications with the entire winder crew, line of sight operations, A cutoff knife has moving parts and may be in different positions at different times in the normal operations of the winder. Each winder crew member must understand the operations of the equipment in all modes: automatic, semi-automatic, and manual modes. Clean-out modes have their own hazards. Some cutoff knives are pneumatically held in place. Some delays occur when using pneumatics, especially when bleeding off the pressure to allow gravity to lower the blade into the clean-out position. Remember that a cutoff knife moves in both directions and creates a pinch point in both directions. A cutoff knife is extremely sharp. Use extreme caution around the knife. Sheet break, hay out. When there is a sheet break causing a hay out, the winder crew members must stay very aware of many things, especially during the cleanup of the winder. Note that coasting winder rolls, lead-in rolls, slitter rolls, etc. are common and sometimes hard to identify. Be aware of hot pieces of equipment in the area that may have been heated by friction. Some of the pieces of the winder may be moving into clean-out positions or being moved to free paper, winder drums, kicker, rider roll. During the cleanup, it may be necessary to kick out a small diameter set of rolls. This, too, has some hazards associated with the small rolls. If you need to place your body or any part of your body into the winder itself, other than your normal safe practices, you must lock out the winder. Generally speaking, body parts should not be placed into the winder without proper lockouts in place. Always maintain a safe distance from the reel and spools to avoid being caught by the paper during a sheet break or hay out at the winder. The safe distance must be established and communicated at each mill. Paper grades, types, winder speed, number of sets on reel, etc. may cause this to vary. Suggested reasonably safe distances would be never less than 4 feet and generally not greater than 12 feet. Hay out, cleanup, and slabbing. When you are slabbing the broke that has been created, there are many hazards to consider. Slips, trips, and falls can occur on broke that is on the floor. Be aware of any mobile equipment that is being used to move and handle the broke. Watch where people are. Only workers should be in the area. Understand the crane operations while removing parent reel for cleanup and never walk under a suspended load. When you are in the slitter area, be aware of all moving equipment and allow equipment to come to a complete stop. Be sure to wear your personal protective equipment, such as cut-resistant gloves for working on or around slitters, knives, sheet cutters. Always know where the slitters are in relationship to your own body parts. Make sure that the proper guarding and signage is in place. When you are in the drum area, these hazards may be present. Be careful around the ingoing nip of the roll and the front drum. People have been seriously injured and killed at that point. Know that fellow winder crew members could be slabbing paper off of the drums or rolls. Look for paper that may be wedged in framework, chucks, slides, rider roll, etc. Be aware of paper under the drums. When retrieving paper, you must be aware of your hands and what they will come in contact with. Use grabber tools whenever possible. Underwinder and cradle. There are specific rules for going under the winder that must always be followed to ensure the safety of those entering this area. The rules should include proper lockout and testing for a zero-energy state. There must be clear communications with the entire winder crew. The winder operator must be able to see or have someone see the person under the winder. If cradle access is permitted, there must be a clearly defined safety procedure. You may need to access the cradle when a cradle is in the roll accept receive position. Proper safety procedures and lockout must be followed, which should include isolating its movement electronically and mechanically to prevent any accidental movement. A full lockout of the cradle is necessary when performing other than normal safe practices. This is any time, but not limited to, crew members having to stand on, kneel on, or lean against the winder drums. You may need to lock out additional equipment depending on the task at hand. Some of the other pieces of equipment to lock out may be the drums, rider roll, nip barrier, roll kicker, and maybe others. Roll ejector, kicker, pinch points. Be aware of the roll ejector or kicker as it creates pinch points as it moves. The operators and crew should know where each point is and always be aware of them. Make sure that proper signage is in place to identify these hazards. The winder may have to eject small diameter rolls, and the roll ejector may not be able to do it automatically or by itself. When operators are required to physically assist in the removal of small diameter rolls, proper safety procedures must be followed. This may include a partial lockout designed for the task, or even a full lockout. Some winders have equipment that can eject small diameter rolls and avoid manual removal. A winder that is running at full speed can encounter a paper variation that can cause the winder to vibrate excessively and kick out a winding roll or rolls. Core chucks can fail or unchuck while at speed, and a roll can be kicked out. Most modern winders have safety equipment built into them to contain the winding rolls, but if the roll is small, it can be extremely dangerous. Rolls have been thrown out of winders or into nip barriers. Be aware of this possibility. Roll discharge. After the cradle has received a roll set, it will begin moving down from the accept-receive position to an intermediate position, or it will discharge the rolls. No one should be in the discharge area at this time. The rolls are heavy, and you must never try and stop them with your body. You can get severely injured. If the cradle fails electronically or mechanically during lowering, this can cause the rolls to be thrown from the cradle. Be aware of this and stay out of the discharge area. Stopping the cradle short of its full down position can cause the rolls to accelerate out of the cradle by dropping off the edge. Some rolls can be discharged so fast that they may jump the stops. The area after the stops should be restricted, and anyone in that area must be notified of this possibility. Narrow or butt roll SOPs. Be careful when handling narrow or butt rolls. There should be safe SOP guidelines for handling these rolls because they can tip over easily and injure someone. A safe guideline might be to band together narrow shipping rolls to stabilize them for transport. Rolls that have a 4:1 or greater height to width ratio may have to be banded depending on the paper grade. It is recommended that 13-inch wide rolls that are 50-inch in diameter should be banded together. Never send a narrow roll by itself on a conveyor, or it will tip over. Piggyback or sandwich the narrow roll with a larger width roll to stabilize the butt roll when stopping a conveyor. Note that this is for rolls to be culled that have to ride the conveyor to get to their destination. A crew member can help stabilize the narrow roll against the larger roll when they are traveling down the conveyor. When at all possible, avoid putting narrow width rolls at an end cut on the winder. Position the cut where it is inside larger width rolls for stability when they are released from the cradle and bumping into stops. Housekeeping, narrow rolls. It takes very little time to tip over a narrow width roll. Housekeeping is extremely important. Loose broke, core plugs, caps, wedges, uneven surfaces, etc. will and have toppled over a narrow width roll. The roll deck needs to be kept very clean and well maintained. When behind a set being released from one set of stops to another set of stops or conveyor, never try and hold back a butt roll to be taken elsewhere. Rolls should only be held back when they are not in motion. You can smash your hand or fingers between the adjacent roll and the butt roll if you try and hold back the butt roll while it is in motion. The chance of a narrow width roll tipping over must be minimized. Not only is it a concern of the roll falling onto a body, but dealing with it afterwards. These narrow width rolls can weigh 500 pounds or more, and picking them back off their sides can be a safety concern that can cause back strain or the danger of it toppling back over. Roll separation. Some winder cradles have curved surfaces to help spread the rolls, or they may have a curved Teflon bump strip to help separate the rolls. It still may be required to separate and break apart rolls that are run together because of unsuccessful spreading at the winder. A conveyor-type roll breaker can help to break apart stuck rolls, or they may have to be separated manually with a hammer and wedge. Beware of the tools needed. The hammer and wedge should be in good condition so they don't break apart. The hammer may recoil and strike a body part, or a hand or fingers may be accidentally hit by missing the wedge. Pry bars can slip. All tools must be picked up from the floor after use and stowed in their proper places. Toe pinch point, taping rolls. A serious toe pinch point exists when the cradle is moving to the lowered position to the floor. It will crush your foot. Be aware of this dangerous hazard. Make sure that all of the available warning systems are functioning properly, which may include rubber strips on the discharge end of the cradle, warning lights or sirens, bells and whistles, labeling and or warning signs, photo eyes, or electric e-stops. Each mill is responsible to develop a safe procedure for taping finished rolls and plugging cores. The cradle and the rolls must be stopped before taping any finished rolls or plugging the end rolls. Never stand in front of a moving cradle. Each mill should identify the safest method to use for taping rolls at their mill. Roll discharge area, multiple roll stops. Some winders have multiple stops before a conveyor and a final stop, and some winders have only one stop at the end of a conveyor. Never enter the area when rolls are in motion. Never get in front of rolls and try to stop rolls by hand despite their size. Proper safe techniques should be followed so that crew members will not sprain or twist a knee or otherwise injure themselves. Rolls must have come to a stop before a person goes into a discharge area. Never ride the conveyor or the roll under any circumstances, even when you are still finishing the roll or labeling. Cradle pinch points. The cradle pinch points hazards can be minimized by applying some or all of these following items. Manual hydraulic isolation valves should be installed on both front and rear sides of the cradle. This creates a mechanical form of protection from cradle movements while employees are between the cradle and the drums. This is a deadly pinch point. Electronic isolation, such as barrier mats, light curtains, and gates with proximity switches, provide electronic isolations to minimize exposures as well. Bump strips have been installed to stop the cradle movements when employees are working around the area as well. Bump strips are designed as a pressure switch which activates or deactivates something when it senses pressure or is bumped. Electronic safety devices should be inspected and verified on a daily basis with documentation. Safety practices. There are some common, basic safe practices that must be followed when working at and around the winder operation. All winder crew members must be trained in the safe operations of the winder. Standard operating procedures must be at the core of the training process. Winder crew members should know how to quickly access the SOPs, and more importantly, the SOPs should be followed to ensure the safest and highest quality operations of our winders. Those who operate and support any part of the winder must be familiar with and aware of many processes, operations, and methods on this complex piece of equipment. These would include the automatic and semi-automatic set change operations and their associated equipment, all aspects of threading the particular winder that they are working on, the entire splicing method, especially on the front drum. Operators must understand the danger associated with the ingoing nip at the front drum during this process and be aware of what the other crew members are doing in this team effort. Crew members must know and understand their site's emergency response procedures. This includes the extraction method for removing a person from the nip formed at the front drum. Winder crews and emergency response teams should practice the front drum extraction method on a routine basis. Knife safety is also important at the winder. The best methods for safely using utility knives during normal operation can be found in the Weyerhaeuser Stanley Knife Training Program and later in this CBT. Automatic set change. All winder operators and crew should know what automatic set change equipment moves and when. Most automatic operations include the automated movement of the core inserter or injector, the core chucks, cut-off knife, sheet clamp, and holders. Also included in the automatic set change modes are the rider roll, nip barrier, roll ejector, and cradles. Hazard assessment and recognizing hazards is virtually impossible to crew members who do not understand the automated sequence. Once the automation sequence is understood, all winder operators and crew members should be able to identify all of the possible nip or catch points of an automatic set change process and be able to protect themselves. Threading the winder. All winder operators and crew members must be trained in and qualified to thread the winder. This training should take place during the skill qualification process. The crew member who chucks the unwind clutch into the parent reel must be aware of this dangerous pinch point. Thread speeds should be set at a maximum of 30 feet per minute to minimize the extent of personal injury in the event that a person comes in contact with an ingoing nip. The lead operator must monitor crew members at all threader pans and areas of ingoing nips. Line of sight operations is an essential part of the threading process, where manual intervention is needed to ensure tails are placed into threader pans. Proper guarding and signage to recognize the nip must be in place, and an e-stop button should be within reach. Be aware that a sheet clamp or holder may be an ingoing nip. Be aware that the edge or trim slitter blades are normally engaged, forming a dangerous and sharp nip. To minimize the hazard associated with the nips at the cores, it is a safe practice to perform threading operation with the cores unchucked if paper weight and type permits. Be aware that the core chucks are disengaged and could be engaged remotely during automation. The operator must see the core chuck area before engaging the chucks. If it is not possible to thread without core chucks being chucked, then a written safety procedure is required on how to safely thread the winder while minimizing exposure to winder operators. Overhead hazards include the rider roll and, on some models of winder, an additional nip barrier. While threading and working in the roll pocket area, be aware that the rider roll is suspended directly above the cores in the up position. There should be a safety latch to ensure the rider roll will not drop on its own. When operating the rider roll, line of sight operations will be necessary to ensure the safety of those in the area, and should never be lowered with people working in the winder pocket area. A significant hazard exists between the cradle and winder drums. This pinch point has caused fatalities in the past, and Weyerhaeuser has placed additional safety equipment beyond that of the manufacturers to reduce the likelihood of anyone being caught in that nip. There must be an electric device or button to kill control power to the cradle and the additional manual hydraulic valves for isolation. These will stop the cradle in its current position. If gloves are worn to protect your hands, they must be tight-fitting gloves. A loose-fitting glove can be grabbed by a nip, especially during threading. Front drum splicing. All winder crew members must be fully trained in specific safe procedures, SOP, for performing front drum splices. The winder operator must be able to see everyone working in the winder drum area during the front drum splicing operation. Line of sight operation from an e-stop is critical. Line of sight operations can be performed with the help of mirrors and cameras where applicable. Any member of the winder crew may stop the winder splicing process if something is out of place or upset. No job is so important that we can't take the time to do it safely. The operator who is running the jog, thread, spring switch must also have access to an e-stop button and maintain visual contact with crew member working in front drum area when threading for a splice. The jog thread button should be a spring switch which must be held down for the winder to operate and located where the operator can see his working partner. The ingoing nip formed by the winding roll and the front drum is extremely dangerous and unforgiving. If your mill site requires winder crew members to be exposed to this nip as a part of the front drum splice procedure, your winder should be equipped with a foot switch located between the front drum and lowering cradle that acts as an e-stop. The winder must also have a full-width e-stop device such as a kick switch or photo beam. This allows for anyone making a splice can stop the winder immediately. While dressing the splice in the winder, be aware that the rider roll is suspended directly above the partially built rolls. There should be a safety latch to ensure the rider roll will not drop down on its own. When operating the rider roll, line of sight operations will be necessary to ensure the safety of those in the area and should never be lowered while crew members are working on the splice or the rolls. To minimize injury in the event a crew member gets caught in the winder, the jog and thread speeds should be set at 30 feet per minute maximum. Think before you act. If a wad of paper or that new tail is going into a nip under the spliced roll, let it go. Do not try and get it. Stop the winder. Extraction plan process. In the event of an emergency, all winder operators should know how to activate the emergency response process for their mill. Each mill should have a plan in place to quickly respond to a person being caught in the nip at the front drum. There shall be a process and tools available to safely remove someone without hurting them worse and without hurting others. Each mill will establish regularly scheduled training on the extraction plan and will practice the process at least once a year. All mills are encouraged to practice this on a much more frequent basis. It is important to store safety extraction devices in a cabinet to ensure easy, quick access to the device when needed, and to assist in keeping the device in good working order. This is a list of mills who have extraction tools developed and in place. Knife and hand safety. A utility knife is frequently used in the winder operation. Common safe practices include: wear cut-resistant hand and arm protection as defined at your mill site, putting the knife in its holder or sheath when not being used. Never using dull knives. You have to work harder and need more force to cut. When changing blades, ensure the dull blades are disposed of in an approved receptacle. Hold the knife firmly so that it doesn't slip, and never cut towards any part of your body. Do not work with two tools at once. Many Weyerhaeuser injuries have occurred when working with an unsheathed utility knife in one hand and another tool in the other hand. Additional safety training for using utility knives can be found in the Weyerhaeuser Stanley Knife Training Program. Core handling. Cores are routinely handled by loading them onto a core loading table or into a core loader or into the drum pocket manually. Larger cores can be heavy and must be handled more carefully. Never reach into the winder, and a core loading stick or device should be used. Other hazards are twisting your knees and back, repetitive motion, standing long periods on concrete surfaces, wrist fatigue, and injuries from gripping and handling. Soft tissue injuries have occurred in the past due to the repetitiveness of this process. Be careful handling cores. To help eliminate injuries taking place while handling cores, the following tools should be considered: ergonomic studies, job rotation, safety mats, etc. Winder Operation Safety Summary. This program has described the extreme importance of winder operation safety in our paper mills. We have shed some light on some of the known hazards associated with the operations of our winders. Each mill is expected to utilize the content of the CBT and to do an internal check assessment on their winder safety practices and procedures. A winder safety audit process is under development and will be available to all of the mills by year-end 2006. Each mill is to have a well-defined winder safety checklist of activities, frequency, and accountable person for each activity. We have learned that there are many general winder safety expectations and that every winder is unique. We must know the hazards of each winder that we work on. We have learned that there are many safe practices that must be followed during the operation of a winder, from threading, splicing, and core handling. Operators on a daily basis are expected to observe safety devices for proper condition and function. Immediately report any issue or malfunction. But the most important lesson from this winder operation safety training program is that it depends on you. No one can do it but you. You are the most important part of any winder operation, and your safety and the safety of all persons around a winder is the most important thing to Weyerhaeuser. Winder safety can be as simple as knowing what the hazards are and then not allowing ourselves and others to come into contact with those hazards. Have the courage to intervene and be safe.